Let's look at a simple example of the general result that we just derived. So here I have an L-shaped object, and I've labeled a couple of points A, B, and C. And I'm giving a characterization of the force system that's acting on this object with respect to point C. So we have a force in the y direction of 10 newtons and a moment of 3 newton meters located at point C. And let's find equivalent characterizations in point A and in point B. So for all of these systems, I'm going to have that R, the resultant force, is always going to be 10 newtons in the y direction. So this never changes. So once you know the resultant force, you know the resultant force. The only thing that changes is the resultant moment. So let's go ahead and calculate the resultant moment. So we'll start with point A. So the resultant moment in point A is going to be the resultant moment in point C plus the vector that connects the 2 points. So it's going to be the vector RAC cross the resultant. So RAC is minus 0.3 EX crossed with 10 EY. So this is equal to minus 3 EZ, and so in total we'll get 0 EZ Newton meters. Okay, so the final characterization in A then is 10 EY newtons and then 0 for our moment. And you can put whatever units you want there, but since the value is 0, it doesn't really matter. Okay, so that's the characterization in A. So pictorially, I could draw this simply as a force of 10 newtons acting in the y direction at point A. And this is the same thing as my original characterization, which if I were to draw it, would look like a force of 10 newtons acting at point C along with a moment of 3 newton meters about the z-axis. So those are two exact equivalent characterizations of the same force system, just acting at different points. So here at point A and here at point C. We can do the same thing to find the moment relative to point B, and we can go ahead and do that starting from our result for point A plus the vector that runs from B to A, cross product with the resultant, and we have 0 for the moment about A, and then we have minus 0.15 EY for the vector that is connecting B to A, crossed with 10 EY. EY cross EY is equal to 0, so we again get 0. So the characterization in B also looks the same. So it's 10 EY newtons with a moment that's 0. So pictorially, I could draw it as follows, and this picture here is an equivalent picture to either of these two that I drew up here at the top. So these are 3 equivalent characterizations of the same force system, just represented at different points. So in the lower case over here is at point B, and in the upper 2 cases at point A and point C.